So we're going to review functions and their graphs. Function. Here are some key terms that you need to know. It's a process that takes an input and produces an output, such that for each allowable input there is only one and only one output. A domain, the set of allowable inputs. The range, the set of outputs. So, for example, if an input is a person and their output is their eye color, there's only, so that for every one person they only have one eye color. The domain is the different types of eye colors that they can have, and the range is that set of outputs. Let's try some examples. So, functions and their graphs. Identify the domain and range. Tell whether the relation is a function. So for A, if you input -3, you get 3. If you input 1, you get -2 and 1. If you input 4, you get 4. Or if you input -3, you get 3. From 1, you get 1. From 3, you get 1. And 4, you get -2. So, which of the following is a function? So, again, going back to our definition, a function, a process where for every input there's one and only one output. That means it has to be B. For every input there's only one output. Unlike in A, for every input, see here, there could be two outputs, which is not true if it's a function. Another thing that you learn is the vertical line test. It is a function if and only if no vertical line intersects the graph at more than one point. So plot the points, -3 and 2. So -3 and 2 around here, 4 and 3, and -3 and -4. Is this a real function? Which point would need to change to create a function? And what could you change to it? So, why is this not a function? Since we graphed here at -3, 2, and -3, 4, a vertical line could pass through -3 and hit 2 points. This makes it a non-function. So we would just need to change the -3 into another value, like 5 or 2. Okay, the next part. Graphing linear equations. If we haven't gotten into this, you will, and you'll always need to know the slope-intercept form. Y equals mx plus b. Or you can think of it, your mama's ex-boyfriend. Steps to graph a linear equation. 1. Write the equation in slope-intercept form by solving for y. So you always want it to have set up like y equals a number times x plus another number. Then you find the y-intercept by making x 0. So if you plug in x, 0 for x, then you solve the equation here, you're going to get y. Number 3, find the slope and use rise over the run to plot the point. Number 4, draw a line through the 2 points. So, if you can graph y equals 1/2 x plus 4, pause the video and see what you come up with. So, you should have gotten, first, step 1, write the equation in slope-intercept form. Yes, it's already in y equals mx plus b. Find the y-intercept by making x 0 and plot the point. So when we make x 0, y equals 4. So when x is 0 here, we would plug in the value around 1, 2, 3, 4, somewhere around here. And then find the slope. Use rise over run to plot the point. So again, the rise, how much does it rise here? 1, and it runs 2. So then we would just rise up 1, but run 2 to get us that 1/2, and then draw a line through the 2 points. So try this one on your own now. Pause the video and solve it. So we have graph 2x plus y equals 10. Remember, we have to write the equation in slope-intercept form by solving for y. So that means we have to subtract 2x from both sides. So that equals 10 minus 2x. But since we want it in mx plus b, we'll rewrite it as y equals negative 2x plus 10. So when we plug in next y-intercept, make x 0, it means y equals 10. So when x is 0, y equals 10 up here. And then we find the slope. It's a negative 2. So the rise is go down 2 across 1 and run across 1. So here's another example, but let's skip ahead to slope, parallel, and perpendicular lines. So make sure you know this formula for slope. M equals y2 minus y1 over x2 minus x1. The parallel lines, if and only if they have the same slope. So when you see something that has the same slope, they're parallel. They're perpendicular if their slopes are negative reciprocals of each other and equal minus 1. So if you get m1, slope 1, times m2, slope 2, and that equals negative 1, then it's a perpendicular line. So why don't you pause the video and try example 1. Okay, so let's just try line 1. So you should have set up it negative 1 minus 3 over 3 minus negative 3. So negative 1 minus 3 is negative 4, and then 3 minus negative 3 becomes 3 plus 3, which is 6. So negative 4 over 6 equals negative 2 over 3. Okay, I also want to review graphing linear inequalities. So to graph linear inequalities, you want to graph the line. Remember to rewrite it to y equals mx plus b. And this is important. You want to write a dotted line when you see less than or equal to, a solid line for, a dotted line for less than or greater than, a solid line for less than or equal to, or greater than or equal to. And then test the point not on the line to see where to shade. If it's true, shade in that area with the tested point. If it's false, shade in the area opposite of the tested point. So for example, if I had to graph y equals negative 2, I would first write it as y equals negative 2. So if y equals negative 2, I'm going to go on my y-axis, and I know it'll be here at negative 2. I would just draw a straight line here, but then I would check that it's a less or a greater than sign. So I'm going to use a dotted straight line at negative 2. So all across here, dotted straight line. So since it's less than, I always go below the line. And to test the point, if I graphed it here at 2, it would say y is, if y were positive 2, it would not be true, because positive 2 is greater than negative 2. So try out these two examples and then check your work in class.